Okay, this is the tutorial for the S60-131 CAM. This is the secondary piston cylinder, and it has the grooving and a hole all the way through. And it's actually not too bad. It should be similar to some of the parts you've done so far. All right, we're going to go to Solid Works. And we have our part. And again, we're going to be in the CAM mode, and we're going to go all the way to the right on the menu. We're going to highlight the operations, and we're going to create a job. Again, we're going to switch it to mill/turn for turning. And our comment is going to be S60-131 turn complete. And then we're going to change to a, okay. And our axis orientation looks close. We're going to go scroll down. And we're going to use Z-axis and X-axis. Select the end of the part. Our origin is going to be on model front. We're going to scroll back up to radial stock, and our diameter on this part is 450 thousandths. So we're going to make this out of 1/2 inch stock. So we go back to our calculator, take 0.5 minus 0.450, gives us 50 per side, divided by 2. We need to put 25 thousandths of stock on the exterior. We're on the front side, we're going to put extra 10. Okay, and on the back side, we're going to again put 2 inches. And we're going to say that 1.6 is inside the chuck. So it'll look like that sticking out of the chuck. Okay, we scroll down farther. Our program name is going to be 131.1. The S60-131 op 1 the lathe. And we'll leave everything else the same. So we're going to accept that. Okay, and then we're going to change the name of the job to the S60-131 op 1 the lathe, so that's consistent. Highlight that operation. So just like our previous operations, we're going to come in with a facing first. So here we go. We're going to turning, and we're going to do a turning face. We're going to use tool number 1 from our library. Okay, I'm going to leave this stuff at default. We're going to go to the geometry. Got our geometry already selected. We're going to go to our operations. Yes, we're going from stock OT from outer radius, from stock OD. We're going to go from the model to the model ID, and we're going to go a little bit past by 0.01, which is 10 thousandths. So we cut past center line. We're going to leave everything on the next tab alone. We go to the last page and we're going to change our entries. So we don't want our lead and lead out the same. We want the lead in to be 90 degrees and we want the lead out to be at 0. Okay, so that we feed in and pull out. And we're going to accept that. So now we've got the first routine, which is the turning the face. Now we're going to turn the exterior. So we're going to go to our turning tool and we're going to turn a profile. Okay, and we need to make sure we have some settings correct, but we're going to go to our turning tool, OD turning tool, which is tool number 3. Okay, and then we're going to go to the next tab, 0.180, because remember we want to go 180 thousandths farther for our parting tool. Okay, our clearance, we're going to leave those. Okay, we're going from the stock OD to the model OD. So that's the range that we're cutting between those two cylinders. We're going to go to the next tab and we're not going to allow any grooving. Don't allow any grooving. And we're going to leave all these settings at default. And then we're going to go to our turning. And we want our lead in to be at 0. And our lead out okay, we're going to go 80 thousandths at 90 degrees. Okay, so there we've got our profile. Okay, so we've turned the outside and we've faced it. Now we want to either drill the hole or do the fins on the outside. Now typically I try to leave as much mass as possible for our cutting. The cutting we're going to do on the exterior is going to put quite a bit of force on the part with the grooving tool. So I think in this instance it may be a mistake, but I'm going to do the grooving first. And we could always reverse the order of that the next time we run the part. We should have plenty of coolant flowing through. It's going to reduce the rigidity for the drilling, but then the drilling is going to go straight into the part as opposed to putting side forces on it. So without any further ado, we're going to put the heatsink groove. Okay, so the next step is to do the grooving. Now it's critical that you make sure that your tool is designed so it's smaller than the actual groove, the same size, or it'll not succeed. So I'm going to use the turning single groove. Okay, operation, we're going to pull our 1mm grooving tool from the library, which is tool number 4. And we're going to leave these at default. We're going to move on to geometry, and here we have to select some geometry to tell it where the groove is. And you should be able to select the outside edge of each of the grooves. Now you could do it this way, or you could do one groove and do what's called a pattern. If you do it using this method, the rapid movements should be a little more efficient. Now you notice I'm picking on this tool and it's offsetting to the tool path to the center of the groove. So you have to set that parameter based on how you're actually going to zero the tool in. So it's actually easier to make the alignment to the back. And that way when you're touching off the tool, it's a little easier to set up. Okay, so we're going to go to the back of the groove. We're going to tip alignment. And we're going to go to the next tab. And we should have our retract from the outer radius. Our outer radius is going to be the model OD. Okay, and so at this point we're going to select the bottom of our groove, so that'll define how deep our groove is going. So we're going to go to the face I just selected, which is the bottom of one of the grooves, which will set the parameter for all of the grooves. Okay, we're going to move on to the next tab. And we're going to leave all this at default. And this at default. Hit accept. And we have our toolpath. It comes in and plunges for each of those grooves. Okay, the next step is we're going to drill out this hole. So we need a spot drill first. Drilling. Pick on our drill tool. Okay, we're going to select our spot drill from the library. Okay, going to go to the next tab. We're selecting our one hole. Go to the next level, our heights tab. So our retract height is actually going to be from the model top. Our top's from the top of the hole. And we're going to actually, for this, the depth is going to be from the top of the hole as well. Then we need to calculate our diameter. So if we go back to our calculator and we put in 200 thousandths, divide that by 2, and we add 10 thousandths, we get 110 thousandths is our depth. Don't forget the point before that number, because there we go. So we should have a chamfer in there. That's kind of funny. It interrupts it where the grooves are, even though the grooves aren't that deep. Okay, so next we're going to go for a drill bit that's going to go down in that hole. We should change this to spot drill. And we're going back to drilling. We're going to do a drill. And we're going to select from our drill library our 199 thousandths drill bit. And we'll leave all that at default. Geometry, we're just cutting the one hole. Top of the hole, bottom of the hole, our drill tip's going to go through. We want to break through by 0.180. So we're boring. So when we part this off, it parts off nicely. And we're going to do a deep drilling. So we're going to do a deep drilling, and we're going to go 60 thousandth steps. Okay, so there's our major drill bit going through. Now our next thing to do is we're going to use what's called a boring bar. We're going to go back to turning, and we're going to do a turning profile. Okay, and we're going to select our boring bar. We need to select the box that says machine inside, turning operation, and we need to go to the third tab Okay, so for this operation, our boring bar is coming in and taking almost no material off. There's barely enough room for the boring bar itself. So doing an inside profile like this, we're actually going to do zero movement for the retract, but we're going to base our clearance plane off the retract plane. And that retract plane is going to be based off the inner radius. So it's the amount of clearance we have, which is only about a thousandth. So we're going to have a very little amount of movement here. So our boring bar is going to go straight in, and it's going to pull back 5 thousandths towards the center and then pull back out based off these parameters. Okay, so our outer radius, you need to select the bore, and depending on what you modeled that at, I bought mine at the nominal of the tolerance, and it said it had nothing to machine. And so we're taking off almost, about a thousandth maximum. So select the bore, put in 0.001, and then your inner radius is the hole that was drilled before. So from the outer radius, it's 5 thousandths per side, which makes that radius of the clearance to where the tool comes in and isn't touching the hole when it first enters. All right, we're going to go to the next segment, and we're going to leave all this at default, except for we're going to allow radial grooving and axial grooving. And then on the last tab, we're actually going to set this at 0. And we're going to have the lead out same as lead in. Okay, so if we zoom really far in, we should be feeding in, we're cutting. We get all the way to the end of the bore, it's going to pull back, and then it's going to wrap it out of the hole. We have to kind of look inside it as the rendering is hiding it. Okay, so our boring bar goes in, makes the hole a little bit bigger, retracts back out, pulls out of the tool, pulls out of the hole. Okay, now that we're done with turning the inside bore, taking it to finished size, we're going to come back and part the material off. So we're going to go to turning, and it's a turning part move. Yeah, we're going to pick our tool 1. We're going to keep all our defaults here. On geometry, we're going to leave that alone. Change this to outer radius. It's kind of semantics. Our outer radius is actually going to be from the model OD, so it's going to shrink down a little bit because we've already turned it down. And then selection, which is going to be the center bore here. Okay, and that way we're going to cut down to that face, but we're going to go 10 thousandths past. And that way we have a little more efficient cut. Okay, and there we go. We've finished off the Dash 131. Now let's go through a simulation and see what we've done. Okay, so this is the end of the tutorial for the Dash 131. Again, you need to post-process your code. You should have one code file and you should have your setup sheets. And it's going to show all the tools that are used on this one. Okay, so you should have a minimum of 2 files. If you can do the cover sheet that I generated, it's great. I've had a couple students figure it out. But the main thing is to have the setup sheet that's generated within HSM here. All right, I'll catch you on the next one.